We've come to Colorado to visit AVA Solar to see how they manufacture thin-film solar panels and find out how the chemical compound they use could help make them cheaper to make and cheaper to buy. Welcome to Fort Collins, Colorado.
Yeah, the mountains are nice. Pretty sweet. So we're going to go visit Dr. Sampath at AVA Solar. And we're going to check out how they manufacture solar panels, which is something that we've been wanting to see for a while.
Yeah. This process that AVA is talking about is substituting silicon with cadmium telluride.
It sounds like what they're trying to do is make solar panels really cheaply. I want to know how well this stuff performs, too.
All solar panels need a semiconductor to turn the sun's rays into electricity. And compound semiconductors like cadmium telluride are cheaper to use than pure ones like silicon.
Silicon takes a lot of energy to purify the material. It's very highly labor intensive. And I couldn't think of doing that as fast as the cadmium telluride solar cells or as cheaply. We'll go to the lab and we will see where we have been developing the process for manufacturing solar cells.
How's it going? Hey, Keegan? This is Keegan. Keegan, nice to meet you. So actually what we've got is, this is the cad telluride in the raw form, and they come as little chunks of material, and we load those into our process. 20 grams of this material, maybe about twice this, would make hundreds of devices, hundreds and hundreds of devices.
We coat
Hundreds of films. This is architectural grade glass that would be found in your window at home, in the window glass. So we take this piece of glass, and as simple as this is, we put it on the belt, and we turn on our process here, and we wait. Here we can do a continuous feed-through process where we never have to touch it. Yeah, right here at the very start of this box is a heat source, and it heats up our glass substrate to about 500 degrees Celsius. Now in that space, you heat up that material, and you create this vapor.
The cadmium telluride vapor travels up to condense on the glass. Because the glass is cooler, it bonds to it, creating a microscopically thin film.
And so here's another finished module.
Should we make some more?
Yeah, you want to do that? All right, let's head back down to this end. See, and you wouldn't want to put fingerprints on it, but for this, you
like
know,
documented fingerprints?
Yeah. Yeah, you can see them on there.
It's going to be from some unhappy customer with the fingerprint.
Maybe no glue
like that.
panel.
All right. All right, here we go.
All right.
Meet it at the other end?
Yeah.
Good. All right, let's do that. This is really the prototype version of the larger scale, so we could scale it up and get more power out of a larger one.
I'm really curious to know what the next steps are to make it a complete panel.
If we walk over here, I could give you an idea of what the steps are. The first step is what comes out of the machine, and this is the 3 layers on the sheet of glass. Cad sulfide, cad telluride, and then the back layer. What has to happen then is we put a back contact layers on, which is represented here with a carbon layer, and then we etch in with a laser scribes to make the individual cells.
Solar cells need to be etched because you don't want one large cell. You want a series of smaller ones, so that in case part of the panel gets shaded, there will still be cells working at full power.
The way a silicon cell has to be made is they take a thin wafer, cut it, and then they have to actually solder those in series to make them work. The beauty of this is you put the material all on the piece of glass, and then all robotically you etch it out, and you have your complete cell. Also, the amount of material that we use is about 100th what they use in the silicon cells, so that cost of materials goes down. It's just a much simpler, more elegant solution.
Thanks a lot.
Thanks very much.
Appreciate the time.
Yeah,
and good luck.
Thank you, James. Thanks for the tour.
And while we're in Colorado, it's time for some fun. We hear some guys here have figured out a way to put a motor into a bicycle wheel. We want to see how it works, and we want to take one for a ride.